So welcome to this community call on June the 14th. I'm your host, Mark Fussell, I'm maintainer of the Dapr project. We have a pretty interesting and packed agenda for you today. We're going to start off by having a little preview of some of the features that are up and coming in the v1.8 release. If you've been following our project release timeline, at the end of this month, we have the next release of Dapr coming out, which is the 1.8. And so we thought we'll give you some insight to some of the topics inside there. I'll give a little update about what happens with the steering committee and the introduction of the Dapr-Sandbox org and what that means for some of the projects inside Dapr. Archer is going to dive into looking at GitHub workflows, and then we'll end with an open discussion if there are any questions from people. So with that, I will hand over to you, Jeroen, to talk about dead-letter topics.
All right, I will share my screen. And let me know when you can see it. Can you see it?
Yes.
All right. So today we're going to talk about an upcoming feature in Dapr 1.8 called dead letter topics. And this is a very useful feature that has been requested for a pretty long time by users. And what this allows developers to do is to basically deal with messages that simply cannot be delivered to any subscriber because it's a poison message. I'm just going to make this guy, or because the process is constantly crashing, or because of any other reason, like none of your subscribers can actually handle the current message. And so developers want to stop the app from going on this endless loop of trying to deal with a poison message. And dead letter topics basically allow you to take these poison messages and put them in their own topic, which later can be subscribed to deal with these messages. They can either be fixed or dropped or whatever developers want to do with them. But after these messages fail to be delivered, they will go to the dead letter topic and allowing the application to continue processing other messages that are okay to process. And this feature basically applies to all of the Dapr pub/sub components. So this is not component specific. All of the Dapr pub/sub implementations will support it, even pub/subs that don't have this native support, like Redis and others, for example, or MQTT. So this is really exciting because this is another example of Dapr just adding features to native implementations that don't have these features. So that's pretty cool. In this diagram here, we see the publisher on the left sending a message. It's publishing a message to Dapr over the orders topic for the pub/sub component, and then Dapr now tries to deliver the app to the checkout method of the subscriber, but it fails because live, and there is something we didn't expect, and the subscriber basically returns an error to Dapr, and then Dapr takes this message and puts it into the dead letter topic inside a topic that was configured to be named failed messages, which can later be subscribed to. So let's go to code and see what that looks like. I have the Dapr quick start pub/sub tutorial here, slightly modified. There are two applications here for JavaScript called checkout and order processor. And let's take a look at checkout first. So this is a really simple application. It's just sending a single message to Dapr with this payload. So it's sending an order ID, and there is a name field here equal to fifth brother. And it's basically calling the Dapr publish endpoint with the orders topic here and publishing the message, just printing to console log when it was published. So that's pretty much it. It just publishes one message and then exits. Let's see our order processor. This is the same good old subscriber application that you know with JavaScript. And we have the subscription here. So this application subscribes to the pub/sub component, to the orders topic. It's telling Dapr, hey, route my event to the orders topic that sits here. But now we have something new. We were basically telling Dapr, hey, for this specific topic, here's the corresponding dead letter topic, and I'm going to call it the bizarre name of Graveyard 11. And basically, if you look at our code here, we're checking the name that comes with our JSON. So we're actually expecting third sister, but the sending application is actually sending fifth brother. So if it's different from third sister, we're just going to return an error to Dapr, which normally will result in a retry of the topic. And if the message is indeed fifth brother, different from third sister, will basically return 200. Okay, so this is the logic here. And that's pretty much it. So let's run this thing and see what it looks like. So I'm going to run the order processor first. So I have the Dapr CLI. Everything's running locally on my machine. I'm going to do Dapr run. So I'm starting the Dapr CLI. It's going to start my application in the Dapr sidecar. The app ID is called order processor. And I'm just telling Dapr that my app listens on port 5001. So I'm going to launch this. And now Dapr is up and running, and the app is up and running, everything's good. And I'm going to go to the publisher, and I'm just going to run the publisher here. And it's going to send a message. And we can see that the publisher published the data and then it exited. This is exactly what we want. So it sent a message with the name of fifth brother. And if we go to the app here, we can see that Dapr is erroring out because the app returned an error to Dapr. And that's basically it for the application. So we can exit the subscriber app, and this is what I've done here. I've exited the app. And now let's say that we want to deal with this failed message. So what I'm going to do here is actually just take this graveyard 11 dead letter topic, and I'm going to copy it instead of the orders topic. So I have the exact same app, only now I'm subscribing to my dead letter topic. And I'm going to remove this code because this is my very simple fix. I'm just going to remove this, and I'm going to accept any Grand Inquisitor, and I'm just going to run this code again. So we're getting it, and we see that there is no error, and Dapr subscribed to the dead letter topic. It received the fifth brother topic from the graveyard 11 dead letter topic, and it acknowledged it successfully because we have no condition here. So this is all nice and well. And you know, for the default behavior in this, every time Dapr fills a message, it will immediately put it inside of the dead letter topic. But what if you actually want to configure some retries? Well, thankfully, from Dapr 1.7, we have the amazing resiliency policies, and we can basically define this resiliency policy here. I'm not going to show it in action due to time, and we're still working out some kinks here. But this is a resiliency policy that basically says to Dapr, hey, when an inbound event comes for a pub-sub named pub-sub, I actually want you to fire off this retry policy. And this retry policy is pretty simple. It's a constant retry of the messages to my application for a maximum of 3 retries, waiting 2 seconds between each retry. And this is basically how you can configure the topics with retries. So this is a really powerful feature. And like I said earlier, it's going to work on every pub-sub implementation that you have. And yeah, so, you know, try it out. Docs are actually in place. So if you go to the version of the docs that's for 1.8, you should be able to see that. Give us feedback, that'll be great. And try it out in release candidate, and let us know if you're running into any issues or if you've got any other feedback. Back to you, Mark.
That's excellent. I mean, it's a great feature to see come along that'll help us handle with some of those failed messages and what you do with them. Well, I'm going to push back to you then, Jeroen, because you are next on the agenda, because you're going to give us a preview into another upcoming feature in a 1.8 release.
That is indeed true. So let me switch to my other VS Code. Yeah, I'm not showing right now. I'm fully aware. And I'm going to start sharing again right now.
Actually, on that dead letter topic thing, some of the interesting things to handle, often you get in pub-sub scenarios, you know, you might have something like a message request that comes in, and as you showed it, like have an order ID and the order has failed. And that's when you kind of push back on the messages and send them to a failed queue to deal with failed orders, for example, yes?
Yep, definitely. Okay, so let's talk about distributed lock API. This is an entirely new building block coming into Dapr for 1.8. It's extremely powerful. It's really a primitive that allows you to build many interesting things on top of, like leader election APIs and others. And before we go into it, I want to thank Flood, the contributor who basically drove the proposal and the design and the implementation for it. So thank you. If you're watching this, then know this is highly appreciated. You're very active in the Dapr community, so thank you. This is a really awesome example of a community-driven component. When I say community-driven, we're all one big community, but I specifically mean from people who aren't Dapr maintainers or approvers. So what does distributed lock gives us? It's basically a mutually exclusive access to some resource. So we can use it for a myriad of cases. And I think like later election is probably the best example of it. But what this basically does is it allows an application to lock on a resource and have only and exactly only one instance of the application that has access to that shared resource. So in this example here, we have two instances of the same Dapr application. They both have a Dapr sidecar, and they're both trying to lock on a resource. Now, this is, of course, a concurrent lock. So the first application that basically reaches the database will acquire the lock on the resource and get it. And then the other application will basically fail to get the resource, and so any other resources associated with it, will be denied. So this can be pretty useful in letting developers just attach a lock to any arbitrary resource that they want to handle, to have only one and exactly one access to from an instance of their application. In this case, what we're seeing is we have two applications, and the same app that basically locked the resource can unlock the resource. And so at that point in time, other instances of the same application can actually get a lock and update the resource again, but then, only one instance. In this example, we have two completely different applications. So app one and app two are two different app IDs. And they can both share on the same resource ID. So if the resource ID is called, Palpatine, they can both lock on it on the same resource, or on the same row in the database, because there are two different applications. And the distributed lock API is scoped to an application. So if you're two different apps, you can lock on the same resource name, but in actuality, it's going to be a different resource that's getting locked for you. So on the underlying implementation, it's not the same resource if you're using two different applications. So let's see what this looks like in code. Currently, we only have the gRPC implementation of this API, although I put a PR for the HTTP version about 2 hours ago. And this is the Golang version of it. It's actually pretty simple. Implementing a distributed lock in actuality against a state store is an extremely complex thing, because you need to handle lots of things like concurrency and expiry and concurrent access and multi-threaded access from the same application and re-entrant locks. And it's extremely complex. But with Dapr, it now becomes extremely simple. It's basically just this line of code that I'm signaling here. So in this application, I'm dialing to my local Dapr sidecar. This is the same thing you'll see when you're instantiating any Dapr client. So we have the Dapr client here with all of the Dapr API surface, and we're focusing now on the TryLock Alpha 1 version. So the first thing you can see is we're targeting a store name called LockStore. This is basically the implementation of the underlying lock. Currently, it's Redis, and if we look at the component YAML here, this is what it looks like, very similar to the Redis state store or configuration store. If you know these, it's just a lock.redis type with a version and a host and a password. And this is
could you just make your font a little bit larger, because it's kind of a little bit small, just zoom in a bit. Thanks.
Yeah, so this is exactly the same YAML, and this is compatible with all of the other metadata APIs that the state store has. So this is pretty cool. It's actually the same implementation for the metadata parsing and the connection management and all of that. So pretty simple lock store. We have that defined. And then I'm basically telling Dapr, hey, there is a resource ID that I want to lock. So same application can basically lock on multiple resources. right? We might have an app that has multiple threads or multiple requests, and we want to lock on different resources. So this is extremely useful because it just makes one application be able to lock on different resources. So this is the resource ID. I call it 3. I don't know why. I'm not particularly fond of the number, but this is what I chose. And there is a lock owner. The lock owner is basically to enable reentrant locks in the future, but this is mainly to guarantee that multiple threads from within the same application cannot lock on the same resource ID. Okay, so the best practice for this, and you'll see this in docs, is to basically generate your own unique ID per owner lock, and this later gets used in the unlock API. So when you unlock a resource, you basically say, hey, unlock it for this resource ID and this lock owner. Expiring seconds tells Dapr when to expire the lock. Okay, so for example, if you were to write a leader election API on top of this, and I'm going to write actually like a blog post or a tutorial for how to do that, you would basically pull the Dapr API, trying to get the lock. And once you have the lock, then you know that you have become leader. So the lock will automatically unexpire after 10 seconds. In this case, yeah, it's 10 seconds. And of course, we have the error, and we're erroring out if there's an error. What we're getting in return from Dapr for this API is a very simple response. Dapr basically just tells us if this operation was successful or not. If we look at it, there is just success, nothing else. It just tells us, hey, did the lock succeed or didn't it? So let's kick this off. And this is not the correct Dapr run. Let's take the lock API. It should be here. And I'm going to issue a Dapr run command with the app ID of lockers. This is a single application. This is my Dapr gRPC port, and I am telling Dapr that my component sits here inside of the lock store, and I'm just running my application here. So this is basically going to lock this resource and then exit, and it's going to basically tell us if the lock succeeded or not. So let's see how this looks like. So we've just spun up our application, and we can see that we have a lock. It's true, and the application exited. Now, if I fire this again, what we're seeing is that now it's false, and this is because the API is behaving correctly. We are trying to lock the same resource twice from the same application with the same lock owner, with the same resource ID, and it's basically failing. Now, 10 seconds should have passed. So if I do this again and run this, it should tell us that we're successful, and here it is because the lock actually expired. And what I'm going to do now is I'm just going to use resource ID 5, and I'm going to uncomment this code. So what this code does is it unlocks the resource. So I'm going to unlock resource 5 here, and this is going to return a response. So the unlock response has several status messages that can really give us information about how the operation succeeded. And there's a few of those. It's basically lock belongs to others, meaning there's like a different owner that locked the resource. There is success that tells us that we were actually able to unlock the resource itself. And there's an error telling us, hey, there was like an internal error, and there's probably going to be an error that gets returned here. But for now, we're just going to print the status and see what it is. So here I'm locking for resource 5, lock owner you own 2, and then we are unlocking it. So this should basically print out success. Let's fire this application. And we can see that we indeed locked the resource, and the app success is true. And we will fire this off again. And we can see that we were actually able again to subscribe to the application. This succeeded because the last operation unlocked the store, and then we basically unlock this fellow again. Now let's change this lock owner for the unlock API to your own 3. I'm kind of shocked by the fact that there will be multiple your owns in this world. There probably are more, but we'll change this to your own 3. Your own 2 has always been my internet handle, but it's still my demo. So we're changing this to your own 3, and we're going to lock this with your own 2, and then we're going to release the lock for this resource ID, same resource ID, just a different lock owner. So let's see what happens here. All right, so we were able to lock resource 5 with lock owner your own 2, but then we have lock owner 3 trying to unlock it, and it says lock belong to others. It should probably say belongs if we're talking about proper pronunciation or English, not pronunciation, grammar. But this is actually the correct response here. So we were actually able to do this. Let's take a look at another error message that gets returned. Let's say that we're trying to unlock a resource that doesn't exist for whatever lock owner. So let's fire this. And it's returning to us the error lock on exist. And this is true because there is no lock here. It just doesn't exist. We haven't created it. And this really encapsulates extremely difficult business logic to lock on distributed state stores in just a very simple API for both lock and unlock. And this is an alpha API, so be mindful that the API surface might change. It might be susceptible to parameter names being changed. It's just the initial implementation of it. But I think this is extremely powerful. And just like with the dead letter topics, we would love to have your opinions and feedback about this feature. So this is it for this demo. Back to you, Mark.
I love that lock and exist.
Yeah.
The question, what does it actually lock in the resource then in terms of this particular case for the Redis store? What's it actually locking? Is it locking a particular table or a row? I mean, or is it just a lock on whatever you happen to access?
This is for the Redis case, it locks a Redis key, so just a Redis value.
So it locks a particular Redis value that you've accessed, yes?
Yeah.
So if I wanted to do more than one Redis value, I have to take up multiple locks on them.
If you wanted to lock on the same resource, yes, you would have to take multiple locks in turn.
I see.
Arthur has his hand up.
Okay, I have a question. So you mentioned that leader election can be implemented with this API. So do you believe this type of feature on top of the distributed lock API should be handled in the runtime or in the SDKs?
What an excellent question. This is a really good question. You know, when we saw this, we're looking at a really simple programming primitive that can be used for leader election, but it can be used for many other things. So the number of scenarios this enables are many. Leader election is one specific scenario. Actually, I was thinking about this today, and my question was, can we actually enable at the runtime both the underlying primitive and a more opinionated programming model on top of it that uses the building block? And so if you think about it, this can actually be implemented on the SDKs, or it can be implemented in the runtime itself. I mean, just imagine, you know, Dapr calling back into the app for like a leader endpoint saying, hey, you've become leader, or leader lost, calling into the app when the leader election is lost. So this is a question that, you know, I think it can go both ways. Personally, I think we could see this in the runtime too. You know, what do you think?
I like to push into the runtime as much as possible. My only concern is, will the callback solution be easy enough to use? Because we have discussed this for PubSub as well, where we don't want to have to force the apps to have a HTTP endpoint to receive messages. So maybe if we have like gRPC streaming as a way to receive those callbacks, maybe that's become more interesting. But yes, I do agree to push the runtime as much as possible.
Yeah. Yeah, and you know, we already have streaming endpoints in configuration. We are seeing issues with these APIs. We've just talked about this morning in the Dapr release call. You were there. So streaming, because it's, you know, stateful streams, you do have some challenges where unary calls are like more predictable in many senses, and they don't require specific IDs. For a session, for example, if you have multiple threads starting different subscriptions. But yeah, I think we can look at each case individually and decide if, streams might be a good implementation for it.
I have another question. Is there a corresponding components contrib API that goes with this? So you can turn this, you have to use that in conjunction with the runtime lock. So in other words, you can implement locking on other components.
So the current component is Redis, but you can write others. It's pluggable just like all of the other Dapr building blocks. So
there's an API from the components contrib side for this?
Yes, correct. Yeah, it's a 3-method interface. It's basically init lock store, try lock, and unlock.
And you'll be able to implement that on, say, another state store, yes? So
yeah,
for example.
Yes, exactly. Actually, what I want to contribute is a native implementation on Kubernetes. Because if you think about it, Kubernetes has a resource ID concept already built into its API. So we could offer leader election without any component if you're running on Kubernetes, just using the Kubernetes leader election SDK. And we're already using this SDK for other things in Dapr. So this should be pretty simple.
Okay, could you imagine it has to be part of some of the state stores we have today, or would you have to do a new implementation? So
yeah, no, so I definitely think most state store implementations that have first right win features can actually become a very easy implementation for the lock store.
I see. So in the same way we put query on top of state stores, we can also put a lock on top of the state stores.
Yes, yeah. I wouldn't add it to the interface, but we could reuse the implementation of it. Just like this Redis lock store reused most of the implementation for the metadata parsing and the connection establishment for Redis.
Right. Okay. I was just wondering if you can reuse it. Otherwise, we end up with a lot of duplicate code around the place, or at least.
Yeah, yeah. In this case, I hardly think it's going to be fragmented.
Okay, excellent. Well, it's exciting. We'll see what happens and see what people use it for. And we'll see some of the scenarios that people come up with. All right, let me share. Any other more questions before we move on? All right, then let me move on and let me share my screen here a moment. So I thought I'd give you a little update about the steering and technical committee and some of the things that have been happening inside all of that. For those of you who are not aware, there is Dapr has a steering and technical committee, and there's a charter here. If you go to the Dapr community repo, you can read about the steering committee here. The steering committee consists of a set of members across a variety of different organizations, and they're responsible for looking at some of the broader issues and topics that span across multiple issues and the project roadmap and generally where the overall project direction is going. And each month we meet, we raise various topics, and you can see the actual topics that get raised in the agenda items that get raised as part of issues. So feel free to read these. They're very open. If there are particular topics that you want to hear about or particular questions you think the steering committee is responsible for, particularly in terms of sort of the larger direction and bigger decision-making across the project, feel free to raise an issue and put it into community repo and mark it for attention to the steering and technical committee. I suggest that you do read the charter of the technical committee because it goes into a lot of detail about what the responsibilities are. One thing I thought I'd just highlight from this was one of the topics that came up that's been ongoing for a while is about that there have been a number of different types of repos that have been put into the Dapr org, and they haven't necessarily kind of taken off very much, or they haven't necessarily matured, or in some cases they've sort of like maintainers that were maintaining have sort of moved on, and they haven't been particularly well maintained in terms of their contribution to it all. So because of all of this, a suggestion that got raised and got approved by the steering and technical committee was the concept of introducing a Dapr-Sandbox organization. And what this means is that it's an organization where it mirrors in many ways the charter that CNCF has, where if you look at CNCF today, they have the concept of sandbox projects that kind of have very early ideas, are very experimental before they move on to incubation projects like Dapr is today, and then eventually to graduation phase inside that. So we decided as part of Dapr, we would introduce this Dapr-Sandbox organization where projects that can either mature and move into the main Dapr org and basically become incubation projects because they are well maintained, can first start off, or projects that no longer are being maintained can move back into the Sandbox org and people can decide whether they want to be picked up again. So you can see we created this Dapr-Sandbox org. It's at GitHub/Dapr-Sandbox. There's a little intro here that just describes the goal of the Sandbox organization. And you'll see that actually, we actually moved 4 of the repos in here that were in the Dapr org. These were one that was based around an early idea around workflows, which was an integration of Dapr and Logic apps from Azure. There was a Dapr extension created for Azure Functions that kind of no longer is being maintained. Very early on in the Dapr project life, someone created a Yeoman generator. And these particular 3 projects were ones that were experimental. They were tried out. They were good ideas at the time, but we've decided to move them back to the Dapr-Sandbox org because they no longer have any maintenance, or they're not really being used heavily in production anyway. And then conversely, very recently, a contributor asked to contribute a Dart SDK to Dapr. And we thought this was a great idea. So, but first off, in order for it to get to maturity level, we put it into this Dapr-Sandbox org here. And at this point, we'll see how this gets contributed to, how it gets added to. And then, if this seems to be taking off, and there's a lot of feedback from the community that a Dart SDK, is at the level of usefulness that it should go into the main Dapr org, we will kind of promote this into the Dapr org itself. And like the other SDKs that are there today, become an official part of the SDK. So I kind of just wanted to make this, aware of this, because this is an interesting place that if you come along and you want to maybe contribute something that's an early experimental idea as part of Dapr, you can bring it here first. You can try it out. This is very public repo. It's, we're very open to bringing in all sorts of different ideas into this. And then as they gain traction, get into the Dapr org. But that way, there's this clear separation between what's experimental phase, what's being worked on or no longer being maintained, and those projects that are in the Dapr org that are clearly, production ready, clearly maintained, and clearly being worked on a regular basis. Okay, so that's.
And I'd like to add that those projects, those repositories, actually, they were moved. If you go to the original URL, Dapr/workflows, for example, GitHub redirects them automatically. So that's a nice feature, so you don't end up getting a photo for. So if you do Dapr workflows, hit enter, it does a redirection. So
that's nice.
That's nice.
Yeah.
Okay, so with that, I will stop sharing. Or at least I will actually return to here and just do this slideshow. And next up, Arta, you're going to talk about GitHub workflows and Dapr.
Yes, thanks for bringing that. Let me share my screen really quick. So that was here in the Dapr maintainers, we were discussing like how can we keep track of our commitments in GitHub, and we came up with some metrics that we can track that in public so we can all see. So we created like a workflow on GitHub that runs every day, and this workflow we basically extract some metrics from the GitHub using the GitHub API and calculate those key metrics and publish them to our Discord channel. Very simple workflow. But when we were building that, we decided to use Dapr. So it is an example of how we can use Dapr even on GitHub workflows. So as you can see, it runs every day. We run a step here to install the Dapr CLI, just like you would on your computer. And then we do a Dapr init. We install the Python utilities because we're using Python in this example, and I'm going to show you the code as well. We execute the step to extract the metrics. And as you can see, we have the environment variable for GitHub metrics path and the GitHub token. And I'm going to show how these are used in Dapr, these environment variables. We also notify the Discord channel. And we also have, again, the GitHub metrics path and also the Discord post URL. And again, we run again Dapr with the components path. And this time is the alert on Discord. In the end, we saved everything we saved the output into the GitHub artifact list. So that's the part of the workflow. Now let's look at the scripts. So we have the GitHub issue metrics. It takes the GitHub token and it makes a, let me go to the beginning here. Uses token to create a GitHub client, right? We'll crunch the API by scanning every single issue that is a type of bug, do some crunching here, do some calculation, calculate these metrics here. And then after it calculates the success metrics, it will output this JSON and use the Dapr client as the via an output binding to save to a file. And the reason why we decide to use output binding is because we want this to be flexible. So in the future, in addition to a file, we can also post to a blob. So that's why you'll see the blob name here as well, because we want to keep this code agnostic of being written to a file or to a blob. And if I go back one more step, we can also look at this alert on Discord. We'll basically use a Dapr client to read the file from the previous step. And again, it could be reading from a blob as well. It would print the text just for visibility and would alert different messages based on different criteria that we want. And these alerts is also a output binding. And this time is outputting to Discord with the content of the message. Now I'm going to show you the components that we used. First of all, we have a secret store that uses local environment, because remember, the workflow defines the environment variable. And then we have the metrics binding, which basically is using that secret of the path to use this as a configuration. So the configuration remains in the workflow, not in the component. So if you can change the GitHub workflow without having to change the Dapr component at all. And we also have the Discord binding, which uses the secret store again to fetch the Discord post URL directly from the environment variable. So this was like the script is running every day. I'm going to show you the results so you can see this, how this runs every day, and uploads the artifacts, notify the Discord channel. Dapr, the output, Dapr here, output is here. The printout of the content is here. All the triage bugs, the bugs that are not triaged, is also emitted here. And then I also quickly show you the post that we get on the Discord channel from Dapr-Bot. So that's the output that we get. So we are triaging 76% of the bugs within 5 days, counting only the issues from the last 30 days, of course. And right now, each week are kind of flaky. We have just 31% success in the previous 100 each test runs. Alessandro is helping us to fix that. And in the future, you can also use the specific action to set up Dapr. So if you don't want to have the script that I have here, that's something that I did with this script. You can also accomplish the same via this GitHub action step that we have available for you, and it's available on GitHub, of course. They also brought up a different topic about how to make service invocation to external services even easier on Dapr. And there's a proposal about that, where we can enable service invocation for non-Dapr endpoints, which means you could theoretically have a service invocation to Discord via the built-in service invocation feature on Dapr, without having to code all the requests yourself on the application. So this could be a configuration, the endpoint could be a configuration in Dapr, including the authentication headers that are needed. So all this could be pre-configured as a building block or a component. We haven't decided yet. And then your app would just use the feature to service invocation. So that's what I wanted to show. And if you have any questions, just thank you very much. Questions?
I have a comment, not a question, but you know, we talked about this before, and this is really cool, showing how Dapr can run in unlikely places, right? Like most people think Dapr can run Kubernetes or container apps in Azure or VMs, but like Dapr and GitHub Actions is pretty darn awesome. I don't know if you remember, but we had a community call about 1.5 years ago where we ran Dapr inside of Jupyter Notebook. Do you remember that?
Yes, remember that.
Yeah, that was very cool. We ran Dapr inside of a Python Jupyter Notebook, getting events from PubSub, and then feeding a machine learning model on the fly. So this is another really cool example of, well, again, Dapr and Python, but inside of GitHub Actions. And I'm really excited to see this, Dapr everywhere.
Yeah, that's really cool. And I think that also my goal is to remove as much of the code of the configuration that we have here and move that inside Dapr as much as possible. So even like the GitHub invocation that we're making here, I at some point I wanted to move all this into a component, so you don't need to do any of this headers configuration or any of this at all. So I think there's a room here for Dapr to do more.
So like writing a GitHub component?
It could be a GitHub component, but like have a generic service invocation with like everything pre-configured. So you could just say, call this API on this service, and that API means doing all of this for me.
Yeah, that's where the external invocation proposal comes into play. Understood.
Yes.
So you're running this now, RTS, and which repo? Does it look at just a Dapr repo?
It's running on the community repository, and I'm looking on only 2 repos for now. I'm looking at Dapr and components contrib. And once we get good at triaging that, and triaging here means an issue has a priority, an issue is pinned, or triage resolved. So that's what it means for issue to be triaged. Once we get good at that, my goal is to expand for us to measure ourselves against multiple repositories. Does that answer your question, Mark?
Yeah, pretty cool. Yeah, excellent. Yes.
Yeah, so I'm personally using this. So I look at this message every day, and I click on the issues that are not triaged and triage them. So this one was labeled as a bug. I took a look at this early today. So I'm gonna mark as P1 for now, from what I read, and Yano can change that later if you disagree. But
it might just be useful though to separate out into the 2 different repos though, because I think that having the statistics on one repo and then the other repo might just make it a little clearer. I think if you bundled all, unless you have expectations that all repos should triage at the same time, which could happen, maybe just seeing the statistics on each one might be a little bit more interesting. It'll only add 6 lines instead of 3, yes?
Yes, I think we can definitely split the metric per repo, in addition to the aggregated number.
Right. Okay. All right, that's pretty cool. Thank you for sharing that. And people can go and try that out in the community repo, yes?
Yeah, absolutely. And then I expect more maintainers also to use this feature so they can keep track of their commitments to the community.
All right, so with that, we really are at the end of our agenda. As we have set right now, we typically have a time for open discussion. So if there are any particular questions that people have, feel free to either just open up your mic and speak, or put something in the chat window and ask questions there. I'll give you a few moments to see if there are any. If not, we'll call it the end of this community call. So let's see if there are any particular questions that people have in any way. Nate, Longdai, Akilia, anyone who's on the call, please just feel to jump in if you have anything.
I just have one exciting update. Exciting in my eyes. We've just merged the first WASM support for Dapr, contributed by Longday. So this is now merged in Dapr. And this is just the beginning for Dapr and WASM. So we're going to have this, star in the community call in its own demo, and it's going to have its own, show and story. But this is really special because it's the first time we actually allow for any way to extend Dapr in a non-Go manner, and also be in a way that's non-compiled into the runtime to begin with. And so this is really exciting. Thank you, Longday. And as WASM matures, we might see more and more use cases for WASM in Dapr.
Yeah, and Longday, if you want to come along and do a demo, feel free to kind of find some time, and we'd love to do a demo of that. It'd be really good. It'd be really cool to show. All right. Well, I'll reach out to you and see if we can find a time for that.
I don't think he can unmute himself.
I will. Yeah, Longday, I've now unmuted you if you want to talk at all.
Or not.
All right.
In any case, this is really exciting.
Yeah, super exciting, the WASM side of things, and making sure that we bring those two worlds together. Okay, well, with that, then we'll call it final for this particular call. Thank you for attending this. As always, these calls get posted up onto the Dapr YouTube channel within the next 24 hours. And feel free to share this. And thank you for attending. And we'll see you next time in 2 weeks' time, where we'll have next call. It'll be the start of, no, it'll be still the end of June. So our next call at the end of June, and we'll be close to releasing the 1.8 release. So we'll cover some more features in the 1.8 release, I'm sure, plus other topics. So thank you, and see you then.
Thank you.
Bye.